So now that I've gone and talked about that, let me talk about virtual environments. Okay, virtual environments are a good thing. And the reason why they're a good thing is they allow you to experiment around with different installations of Python. So, in particular, you can install different versions of Python. So if you want to work on Python 2.6 or 2.7, you can do so. If you want to work on Python 3.5, 6, 7, 8, you can do that. It's just a question of you sit there and say, this is the version of Python I'm going to run. In addition, these things can all be installed locally via a program called pip. And pip is one of these recursive acronyms. It stands for pip installs packages. Okay, it's just like GNU stands for GNU. GNU is not Unix. Okay, and it is a cross-platform package installer for Python, and it can be quite involved because some of these packages come with bucket loads of C++ code or whatever, and so you might have, when you do the install, you might have to download a bunch of C++ code, find a compiler, compile the code, and get it ready for you. And it's way more than I actually understand, so I may have details of that wrong. I used a little primer to learn about virtual environments. There, the URL is right there. Remember, I sent this a link to this talk to the list, so you don't have to write this down. I'd go walk your way through. It's pretty easy. You go pip install virtual end wrapper. You do a couple of edits to bash RC and source it, and then you can create an environment. You have to fill in the right arguments, specify which Python you want, a few other things, and an environment name. And you go work on in the environment name, and now you are in an environment where all of those features that you have specified for that environment are in place. And when you do pip installs, it will go into that environment. Okay, and if you need to try a different environment, you can just create another one, and you go work on that, and it switches you over to that. So you're not into this thing of what I used to have to do, which is I used to have to do super user install of every single package that I needed, and I had no idea about the quality of the packages and whether or not they would conflict with one another. This allows you to make mistakes without damaging things horribly. Okay, so virtual environments, they're a great idea. You should do them. And when you're done with using them, you can do deactivate. The one I'm pointing you at here is kind of more of a command liney style of virtual environments. There's another really popular one called Anaconda, which is a little more graphical user interface-like, and it tends to be oriented towards scientific computing. It's more than Python virtual environments. It's a larger concept, which is they have the larger packages of stuff that you can install in Anaconda. And a lot of people use it. How many people here use Anaconda? Small number. How many people here use virtual environments? Okay, so you people probably found out about virtual environments before I did. Okay. I like to have a required packages file. For some reason, the suffix is REC rather than REQ. I don't know why, but that's kind of the standard. And you just list the packages you need, and then you can go pip install -r and the name of the thing, and it will get all those things installed. Okay. So this means if you have your code up in a repo and you load the repo down, all you have to do is run the pip install command, and it will get everything into your environment correctly. That's the concept behind it all. Okay. So pretty simple stuff. We don't need to spend much more time than that. Whoops. Okay. Setup.py. Yikes. Okay. Python has gone through a lot of turmoil figuring out their packaging system. This should not be a big surprise. Just about everybody who puts together a packaging system suffers a lot. Do you agree, Tully? Okay. Yeah, so there's just a ton of issues to be thought about and worked through, and it took a long time. Eventually, Python decided that setup.py was the one they were going to use. They had another one called distutils, which is more or less gone away. I shouldn't say that, but I don't use it. So the key thing about it is you go import setup.tools, and then you call this method called setup, and you start filling in values, okay? You really should do this, because then you'll be able to use your stuff well in your Python virtual environment. So, you know, author, email, some of this stuff is boilerplate. You probably should pick a license. I tend to use the MIT license. I'm a little biased there. You should have a description. You don't have to encode it in a string. You can read it from another file if you want. There's this thing called entry points. I'm not going to talk about them, but using entry points, you can create executables that you can run in your virtual environment without having to go the exclamation point sharp slash whatever blah 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 stuff that you normally have to do, which I find kind of convenient. It's also cross-platform, so that's kind of the way I generate command line executables now, is with entry points. There's other stuff in entry points that can be used for plugins and stuff like that, and it's beyond the scope of this talk for me to explain that, but it's actually pretty cool. Include package data equals true. Sometimes you need this to make sure that your data files show up in your installed package. There's a whole bunch of issues between manifest.in and setup tools that I do not understand. I just struggle getting the right files in the right places. So if somebody can ever explain it to me, I'd love to figure that out. Let's see, install requires. This is where you list the files that I put in that rec file. It's the same list, okay? And this means that when you install this package, it will go off and find all those other packages and install them as well. Okay, so it's a true package manager. Long description, okay, we don't need to go there. You can specify the standard type for the thing. I tend to use Markdown. I'm a big Markdown fan. And then you have to give your package name, and there's this thing called packages, which lists the package directories. And usually your package name and your package only has one thing, and they're the same. But setup tools allows multiple packages, and I've never tried it. It sounds scary as all get out to me, but I'm sure that there's some good reasons for doing it. But I've never found them. So just wanted to let you know that there's nooks and crannies here or there. There's a lot of nooks and crannies in this setup.py. And then finally, you can sit there and tell the package what level of Python you need, because they keep adding features to Python, and you can say, well, I'm using these features. So like in Python 3.8, they've improved formatted strings even more, and I'm really looking forward to the next long-term support release of Ubuntu, because I'm pretty sure they're going to release on 3.8. I want to upgrade to it, and I'm hoping that ROS will be running on 3.8 on the next long-term release. Do you know? I'm looking at you.
Whatever's in Ubuntu Focal.
Okay, yeah. So I'm hoping 3.8 makes it, so it's released. And then if your stuff is stored in a repository, you specify the repository URL. And if you have a version number, which is it's a great idea, you should specify the version number. Okay, that's an overview of setup tools. You're going to probably need to put one of these together if you really want to use virtual environments correctly. That's why I'm spending all the time here talking about it. It's not particularly fun, but it is kind of boilerplate. Okay. Once you have setup.py, you just go pip install point, and away you go. And if you want to run your package, you go python-m and your package, and it starts executing. Okay? So. Now I want to talk about linting tools. Linting was a concept that was sort of started in the very early days of Unix. This is back when the Unix ran on a 16-bit microcontroller with 128K of memory. They couldn't do all the checking that they wanted to do in the compiler, so they broke it into two pieces. They broke it into the compiler piece and the checking piece. The checking piece was called Lint, as in you would pick Lint off from your program and make it a little better. So that's where the term comes from. There's a whole bunch of linting tools available for Python. And I'm going to be covering something called Flake 8, MyPy, and PyDoc style. The PyTest is not actually a linting tool, I think. That's wrong. And then PyLint is another linting tool, which I just haven't tried yet, but it's fairly similar to Flake 8. Okay. Flake 8, whoops. Flake 8 is a linting tool. You install it the way you see it described there, and you run it. I tend to use line lengths of 100 in my Python code, so I have to specify the line length. If you don't specify it, it defaults to 80. Everybody knows that 80 is the God-given length of a line because that's how the creed it would be back in the 1800s. So anyhow, I use 100 because all I want is something that when I print it out, I can still fit it on an 8.5 by 11 sheet of paper, which is a God-given size, size of paper, right? Okay. Okay. It generates a ton of picky formatting complaints, and I just learned to deal with it. Okay. So it sits there and says you need an extra line here. You have too many lines there. You have white spaces at the end of your line, which you need to remove. You have tabs where you shouldn't have tabs. It just complains about everything. You just deal with it. It also finds some nasty stuff. Okay, for me, I have spent literally days discovering that I had a typo where I was assigning to a variable where I transposed 2 characters. Yeah. And this thing just sits there and says, God, you're assigning to a variable and you're not using it. It's like, thank you. Why couldn't Python tell me that? But so anyhow, this linting tool figures out that stuff that you're not using. Okay, and boy, I wish I'd found this a lot sooner. Okay, let's see. It's huge. It's got a 100-page manual. I have not read the manual in detail. I just kind of use it, stock out of the box. But I think you folks might want to give it a try. How many people here have used Flake 8? I'm just curious. Just a couple. Wayne says give it a shot.
Does it just find problems, or does it auto-fix for you?
No, it just finds them. You got to fix them yourself. I know. I mean, and the thing is, some of the problems aren't really problems. They're just formatting errors. Okay, and so it's like you just sort of say, why is it complaining about this? And you just say, screw it. You just fix it. Okay. So now this next thing is type hints. Type hints has been it's been very experimental. They started working on it back in late Python 2. It was somebody's PhD thesis, and it was an attempt to do static type checking in Python. My general, I used to do compilers for a living, and you sit there and say static type checking in Python, I'm going, no way, can't be done. And the answer is, well, actually, there are rules, and it kind of works as long as you follow the rules, okay? And if you don't follow the rules, it doesn't work, it doesn't find them, okay? So it's a work in progress. It misses things. It rarely complains about things that are correct. In general, you just sometimes you'll get a runtime type error that it just misses. For example, if you're using something called a Python decorator, that tends to shut down the type checking for that method. I also want to point out that when you're using type-hinted code, it doesn't look like the old Model T Python that we started with. It looks a lot more like C, C++, C#, Java. You have your types splattered all over your code. So just be aware that it looks quite different. Okay. I don't mind it. I actually find it useful. I've always been frustrated by the fact that when I'm reading Python code, I really like to know what the types of the things that were coming in are supposed to be, and I couldn't find it. So, and with type-hinted code, it's there. This works best when you use it all over the place. It's not one of these things, it's not a sort of a little bit here, a little bit there. It's like, do the whole module, okay? Frankly, do the whole program, okay? But if you do this, you'll tend to find all the kinds of problems that static type checking can find. And you'll sit there and somebody will say, well, why don't you just code it in C and C++? And go ahead. But remember, it's not, if you miss a semicolon or curly brace, you're on your own. Okay. Yeah, so the compiler, the C and C++ compilers I worked on were horrible about dealing with missing semicolons and curly braces. They've gotten a lot better over the years. And then forget screwing up C++ templates. That was just a disaster. I think that's gotten better too, but I haven't programmed in C++ in quite a while. Just for reference, I'm listing something called the PEP numbers. PEP stands, I think, for Python Extension Proposal. This doesn't, and the type hints are discussed in 483, 484, and 3107. Okay. I will mention that not everybody's gotten the hint on type hinting, and Flake 8 is a little behind the times. And it will complain about stuff that's perfectly valid type hinting, and the only way around it is you actually just put the thing that's complaining about in quotes, because it turns out strings are allowed as type hints, and Flake8 says, oh, I don't care about string type hints, I don't care about type hints. Okay? So, here's how you install it. Pip install MyPy, and to run it you go MyPy module name. Okay, so how do you do this stuff? Okay, the first thing you need to do is you're going to need to import the typing module. Okay, and it defines a bunch of uppercase types. Okay, so there's any callable, IO, list, optional tuple, type, union. These are the ones I'm going to talk about a little bit. I will mention that from 3.7 on, you are probably going to have to add the line of from_future import annotations, because they believe they have made an incompatible change, and so this may be necessary. Since I'm not running 3.7, I don't know this for sure, but this is what I've read. So I just wanted to warn you about that. Okay. Any means any pointer in Python. Okay, so it can be an int, it can be a none, it can be any class, anything. It means that it's runtime type checking exclusively. Callable is used for passing functions around, and it can callable just standing by itself just means that it can be any function, but you can actually put constraints on the callable. You can constrain the arguments, and you can constrain the returns. Dict is the typing syntax for doing a dictionary. So you can specify the key type and the value type of the dictionary. IO is what you use for the, instead of files. I list that because sometimes you want to pass file-like things around. List is for lists, but again, because of the typing module, you can specify the type of the list. Optional, I'll get to shortly. And tuple is for tuples. Okay. And type is for types. No surprise there. And union and optional are very similar, and I'll talk very briefly. I'll talk about that shortly. Okay. The simple types remain lowercase. So bool, float, int, string, complex, probably a few others I can't remember right now. They're still lowercase. Technically, none is an instance of none type. But in typing, they use none instead of none type. Okay, so it's a subtlety, but the code reads better. You just have to get used to it. And so here are some examples here. Dict takes two values, a key type and a value type. List takes a type. Okay, and there's two kinds of tuple declarations. There's a tuple where everything in the tuple is the same, in which case you go tuple type, comma, dot, dot, dot. Or if you're using a tuple as sort of a lightweight data structure where each position in the tuple has a different type, you go tuple and then the types in order. Okay, so I represent that as the type 1 through type n format. Okay, union means that it can be either this type or that type or the other type. Okay, and frankly, I've never used union, but for completeness, I felt it was appropriate to come up here, specify here. There's a subcase of union called optional, which I use quite a bit more frequently. And basically what it says is this thing can either be of type none, okay, or it can be of the type. So this basically allows you, it's the moral equivalent of allowing you to store a null pointer into your variable or the actual type. And then the syntax for callable is not clean at all. You have to put your arguments in square brackets, and I'm not being complete here because I'm not talking about keyword arguments or any of that stuff. And you have to put your returns not in square brackets, but as a common separated list. And if your routine does not return anything, you return none, because technically all Python functions and methods return something. And so if you don't actually specify it, none is what gets returned. So that's the algebra for types using the typing system for type hints.